When I came to the MSSE program, I had the two choices, and I decided that I would rather go for the thesis because I thought that that could give me kind of a breadth of application, that I would have classes to give me kind of the core understanding, but then I would also be able to translate that to a research aspect to be able to produce my thesis, so I can kind of take what I learned and then apply it directly to a problem that I was trying to solve in parallel, as opposed to just having these skills and then further on down the road trying to recall them and work them into what I was doing. My research right now is in the MEMS Sensors and Actuators lab, where I'm developing a integrated microsystem with microfluidics and combined with optics to do bacterial biofilm testing for antibiotic development. So essentially finding a way to make drug screening applications a little bit more effective in terms of cost, overall efficiency, time, things like that. As a graduate student here in the MSSE program, I was able to kind of use my systems engineering side in tandem with the actual research that I was conducting as a graduate research assistant. By essentially, coming into the lab, being able to do my research work, being able to go to class, and then take those things that I learned in class and apply them as I went towards my research. So I could actually improve the processing that I was doing on the actual research side in terms of formulating a problem, in terms of formulating what kind of a system I can develop to be able to solve that problem, and then going on down the line, how to conduct the experiments, how to do some sort of analysis, and looking forward what the kind of cost benefits of this kind of project might be. So I was able to kind of take what I was learning on the systems engineering side and then directly apply it to my real life kind of research that I was conducting here at the university. So I actually have two conference publications coming up this summer. One is in June for the Hilton Head 2012 workshop, which is one of the leading microsystems workshops in the Americas. And that's presenting some collaborative work that I conducted with one of my colleagues in the MEMS Sensors and Actuators lab, men named Youngwook Kim, in which we have taken the microfluidic platform that I developed and then integrated it with a novel biofilm treatment using the application of electric fields combined with antibiotics, and we're presenting that work in Hilton Head in June. And I'm also traveling to Rome this summer for the INCOSE Symposium, which is an international annual conference on systems engineering, in which I'm presenting some sort of essentially modeling paradigms that we can use for the development of biomedical systems specifically. And the reason for that is that since we're working with biology, it's obviously a very variant type of system, so it makes the validation and verification processes very difficult. So what I'm proposing are these different types of modeling paradigms where you can actually kind of set up your system from a systems engineering perspective and use those types of tools to be able to kind of improve upon and develop biomedical systems that right now they're kind of using trial and error, so you can be a little bit more formal method of doing that. Systems engineering concentrates a lot on methodologies and formalisms of how we can actually attack these large engineering problems. So instead of kind of blindly wandering through this path of research, I was able to take the skills that I was learning in systems engineering in terms of the generation of analysis and requirements towards the development of models to actually simulate the system that I'm trying to work with, and then transgressing that into a final product. So I was able to pull some of those skills together and then apply them directly to the problem that I was trying to treat.